Hello. Hello and welcome to this video. This is the 46th set of problems. That is question number 451 to 460 on polynomials and theory of equations. We will study 10 more interesting problems in this video. If you want to download the PDF, the link will be given in the description, and at the end of the video, I'll show how to download the book as well from the website. So I will say what I always say, that when I'm stating the problem, you should pause the video, and only if you cannot solve the problem, you should look at the solution. So without further ado, let's get started. Question 451 says that if PQ be the roots of the equation x square plus bx plus c is equal to 0, prove that b and c are the roots of the equation x square plus p plus q minus pq into x minus pq into p plus q is equal to 0. So fairly straightforward problem. We are given that p and q are roots of the equation x square plus bx plus c is equal to 0. So p plus q will be minus b and pq will be c. Now equation whose roots are b and c is x square minus b plus c into x plus bc. Now we substitute the value of minus b and minus c, we get p plus q minus pq. And we substitute the value of pq, we get pq into p plus q. So very easy problem. Question 452 says that if 3p square is equal to 5p plus 2 and 3q square is equal to 5q plus 2, where p is not equal to 1, obtain the equation whose roots are 3p minus 2q and 3q minus 2p. So if you look at these two conditions, you have got an equation 3x square minus 5x minus 2, that is p and q are roots of this equation. So p plus q will be 5 by 3 and pq will be minus 2 by 3. So equation whose roots are 3p minus 2q and 3q minus 2p would be x square minus p plus qx minus 6p square minus 6q square, and this should be 12. Okay, this is not 13 because no, this is 13. That is fine. 3 3 are 9 and 2 2 are 4. So 13pq is equal to 0. Now we substitute the value of p plus q and pq here, and this p square q square can be written as p plus q whole square minus 2pq. So you substitute and solve, you will get 3x square minus 5x minus 100 is equal to 0. Question 453 says that if alpha plus minus square root of beta be the roots of the equation x square plus px plus q is equal to 0, prove that 1 by alpha plus minus 1 by square root of beta will be the roots of the equation p square minus 4q into p square x square plus 4px is equal to 16q. So we take the sum of roots, that is alpha plus minus square root of beta. The sum will be 2 alpha, that is equal to minus p. Then product will be alpha square minus beta is equal to q. We substitute the value of alpha from here, we get beta is equal to p square minus 4q by 4. Now equation whose roots are 1 by alpha plus minus 1 by square root of beta would be x square minus 2 by alpha x, that is sum of roots, plus 1 by alpha square minus 1 by beta, that is product of roots, is equal to 0. Once we have this, we substitute the values of alpha and beta from what we have obtained, and we simplify, we get the desired equation. Question 454 says that if alpha beta be the roots of the equation x square minus px plus q is equal to 0, form the equation whose roots are alpha square into alpha square beta minus beta and beta square into beta square by alpha minus alpha. So sum of roots would be alpha square into alpha square minus beta square by beta, we take LCM, plus beta square into beta square minus alpha square by alpha. So if you take LCM of both this, you get here alpha cube. when you take LCM and you get beta cube here. So an alpha square minus beta square you take common. So that will become alpha square minus beta square into alpha cube minus beta cube. So the first term you can split as alpha plus beta into alpha minus beta, and you take alpha minus beta common from the second one. You get alpha minus beta whole square with alpha square plus beta square plus alpha beta by alpha beta. You simply substitute the value of alpha plus beta, which is p, and alpha beta is equal to q. You get p by q into p square minus 4q into p square minus q. Now if you take the product of the roots, if you take these two multiplied, then this will become alpha, because this alpha will cancel here and this beta will cancel one beta here. You get minus alpha beta into alpha square minus beta square whole square. Now there could be something which is missing. No, that is fine. The product of roots is minus alpha beta into alpha square minus beta square whole square. Now you split this into two parts, alpha minus beta whole square and alpha plus beta whole square. So you get minus p square q into p square minus 4q. So once you have the sum and product of the roots, you can write the equation as q x square minus p into p square minus q into p square minus 4qx minus p square q square into p square minus 4q is equal to 0. Question 455 says that let A, B, C, D be real numbers in GP. If U, V, W satisfy the system equations, U plus 2V plus 3W is equal to 6, 4U plus 5V plus 6W is equal to 12, and 6U plus 9V is equal to 4, then show that the roots of the equation 1 by U plus 1 by V plus 1 by W into x square plus B minus C whole square plus C minus A whole square plus D minus B whole square into x plus U plus V plus W is equal to 0, and 20x square plus 10 into A minus B whole square x minus 9 is equal to 0 are reciprocal of each other. So we solve the given system of equations, 3 equations, 3 unknowns. We get U is equal to minus 1 by 3, V is equal to 2 by 3, and W is equal to 5 by 3. Now B minus C whole square plus C minus A whole square plus D minus B whole square is A square plus 2B square plus 2C square plus 2D square minus 2BC minus 2CA minus 2BD. But because A, B, C, D are in GP, therefore AD is equal to BC, and CA is equal to B square, and BD is equal to C square, which implies that A square plus 2B square plus 2C square plus D square minus 2BC minus 2CA minus 2BD is equal to A minus D whole square. You substitute here. Once we have that, what we do is we substitute what we obtained in the equation given. So this particular equation becomes minus 9 by 10 x square plus A minus D whole square x plus 2 is equal to 0, which is equivalent to 9x square minus 10 into A minus D whole square into x minus 20. So equation whose roots will be reciprocal of this equation, we determine that. So this is a bit of shortcut. So what we have done here is we substitute x with 1 by x because the roots will be reciprocal. So it becomes 9 by x square minus 10 into A minus D whole square by x minus 20 is equal to 0, which is 20x square plus A minus D whole square into x minus 9 is equal to 0. There should be 10 here, 10 is missing. Yep, there should be 10 here. Okay, so that is a typing mistake. Question 456 says that if alpha 1, alpha 2, alpha n be the roots of the equation beta 1 minus x, beta 2 minus x up to beta n minus x plus a is equal to 0, find the equation whose roots are beta 1, beta 2 up to beta n. So because alpha 1, alpha 2 are the roots of this given equation, we substitute the values. We get beta minus alpha 1, beta 2 minus alpha 2, and up to beta n minus alpha n x plus a is equal to 0. Therefore, equation having the roots beta 1 through beta n will be x minus alpha 1 into x minus alpha 2 into x minus alpha n plus a is equal to 0. Very straightforward question. Now we move on to question 457. It says that If alpha 1, alpha 2, alpha n be the roots of equation x to the power n plus nx minus b is equal to 0, show that alpha 1 minus alpha 2 into alpha 1 minus alpha 3 up to alpha 1 minus alpha n is equal to n into x to the power n minus 1 plus a. So we are given that alpha 1, alpha 2, alpha n are roots of the equation x to the power n plus, there should be an n is missing, plus nx plus b is equal to 0, which implies that x minus alpha 1, x minus alpha 2 up to x minus alpha n will be equal to x to the power n plus nx minus b. Now, when x tends to alpha 1, what we do is we have divided this right hand side by x minus alpha 1. So we apply L'Hospital rule, we get alpha 1 minus alpha 2, alpha 1 minus alpha 3, alpha 1 minus alpha n is equal to nx to the power n minus 1 plus na. So this requires a bit of calculus. You need to know L'Hospital's rule. If you don't know, you can skip this question. And this is equal to n into x to the power n minus 1 plus a. So we have got two typing mistakes. There should be n here and there should be 10 here. Okay. So we have got mistakes in question 455 and 457. I'll fix this. Question 458 says that if alpha, beta, gamma, delta be the real roots of the equation x to the power 4 plus qx square plus rx plus t is equal to 0, find the quadratic equation whose roots are 1 plus alpha square into 1 plus beta square into 1 plus gamma square into 1 plus delta square and 1. So 1 plus alpha square is equal to alpha plus I into alpha minus I. And so for other terms, the first given root 1 plus is 1 plus alpha square into 1 plus beta square, 1 plus gamma square and 1 plus delta square. Now it is given that p of x is equal to x to the power 4 plus qx square plus rx plus t. So we can say that 1 plus alpha square, 1 plus beta square, 1 plus gamma square and 1 plus delta square is equal to p of I into p minus I. Because if you equate this, you get I and minus I as the root. So we substitute that, and upon substitution we obtain 1 minus q plus t plus ri into 1 minus q plus t minus ri. So this gives us 1 minus q plus t whole square plus r square. So the sum of the roots 1 plus alpha square, 1 plus beta square, 1 plus gamma square, 1 plus delta square and 1 is 1 minus q plus t whole square plus r square plus 1. And product is 1 minus q plus t whole square plus r square. So the equation whose roots will be this terminology, this term, that is 1 plus alpha square, 1 plus beta square, 1 plus gamma square, 1 plus delta square, and 1. So the quadratic equation would be this equation. Okay. Now we move on. This is somewhat involving problem, so spend some time on this. Although it is involving, it is fairly straightforward if you understand the concept of equations. Question 459 says that if alpha, beta, gamma be the roots of the equation x cube plus bx plus q is equal to 0, find the cubic equation whose roots are alpha plus 1 by alpha, beta plus 1 by beta, and gamma plus 1 by gamma. So because alpha, beta, gamma are roots of this equation, that is x cube plus bx plus q is equal to 0, from Vieta's relationship, we have alpha plus beta plus gamma is equal to 0, alpha, beta, beta, gamma, gamma, alpha is equal to t, and alpha, beta, gamma is equal to minus q. Now the sum of alpha plus 1 by alpha, beta plus 1 by beta, and gamma plus 1 by gamma is 3 alpha beta gamma plus alpha beta plus beta gamma plus alpha gamma by alpha beta gamma, which is equal to 3q minus p by q. Now product of these three taken two at a time is 3 alpha beta gamma plus 2 into alpha beta plus beta gamma plus alpha gamma plus alpha plus beta plus gamma by alpha beta gamma. So we again substitute these values, we get 3q minus 2p by q. And the product of all these taken together, that is these roots, is alpha beta gamma plus alpha beta plus beta gamma plus gamma alpha plus alpha plus beta plus gamma plus 1 by alpha beta gamma, which is equal to q minus p, and this should be plus 1 because it is plus 1 here. This should be plus 1, not minus 1. Okay. So This is another typing mistake. Once we have these three, we know the equation whose roots are these three roots is x cubed minus sum of the roots into x squared plus product of roots taken two at a time into x minus product of all roots, that is this. So see at the end this is plus 1, so this is definitely a typing. No, this should be minus 1. So I'll fix this question 459. We have three typing mistakes and 455, 457 and 459. Now we come to the last question of this set. Question 460 says that show that one of the roots of the equation x squared plus bx plus c is equal to 0 may be reciprocal of, there is again typing mistake, of one of the roots of a1 x squared plus b1x plus c1 is equal to 0 if a1 minus cc1 whole square is equal to bc1 minus ab1 into b1c minus a1b. So we let alpha to be one of the roots of x squared plus bx plus c. So we have got a alpha squared plus b beta plus c is equal to 0. Now reciprocal of alpha will satisfy the second equation. So we have got a1 by alpha squared plus b1 by alpha plus c1 is equal to 0. That is c1 alpha squared plus b1 alpha plus a1 is equal to 0. Now it is a simple matter of cross multiplication and finding out two values of alpha, which is equal to cc1 minus a1 by ab1 minus bc1 is equal to ba1 minus b1c by cc1 minus a1. So upon cross multiplication of these two, we get the desired result. Okay. So let me verify. Yeah, this is correct. Okay. So with this, we come to the end of 46th set of problems on quadratic equations and polynomials. I hope that you are learning by watching these videos, and if you have not watched other videos on playlist, I will recommend that you go and watch the entire playlist. So thanks a lot for watching the video. I'll see you in the next video with 10 more problems. Till then, see you around.